Hello everyone. What we'd like to do in this video is use the law of cosines to try to solve a triangle. So before we go on to do this, let's go ahead and remind ourselves what the law of cosines says. So if we have a triangle, this is angle A, this is angle B, and this is angle C. This would be side length A, this will be side length B, this will be side length C. Okay, what the law of cosine says, and something I always remember, is that the law of cosines is kind of like a generalized Pythagorean theorem. So, if I start with a squared, then I'm just going to sum the square of the other lengths. So I'll do an a squared is equal to a b squared plus c squared. So I'm starting with something that reminds me of the Pythagorean theorem, but then we kind of have to add this extra piece, or I guess subtract, a minus 2bc times the cosine of A, and the angle that I put here has to match the letter out front. Okay. Similarly, we would have that b squared would be equal to a squared plus c squared minus a 2ac times the cosine of angle B. We'd also have that c squared will be equal to a squared plus b squared minus a 2ab times the cosine of angle C. So there we have the law of cosines. Now, a note, we want to be careful. So a note when using the law of cosines to solve triangles, or just a note in general when solving triangles, is whenever possible, you always want to use the law of cosines rather than the law of sines to find an angle. So I'm going to write when possible. When possible, use the law of cosines to find angles. Notice it says when possible. Sometimes we have to use the law of sines to find angles, but when possible, we'll want to use the law of cosines. And I hope to illustrate this with a couple of examples. Okay, let's do our first one. Okay, so as our first example, let's solve the triangle with, okay, what do we know? Let's say we know that A is 40, we know that B is 44, and we know that C is 12. Okay, so let's go ahead and draw this. You don't have to draw these to scale. I highly recommend it when possible. It'll kind of hopefully alleviate some of the mistakes you can make in your algebra. So here's A, here's B, and here is C. Okay, let's see. Okay, I'm going to notice that C here is pretty small. This length here is pretty tiny. So I'll go here and write 12. Okay, side length B is bigger than side length A. So I don't know, we'll draw B. Let's say this is 44, and then say this here is 40. I tried to draw it so that, I don't know, that this side here is a little bit smaller than 44. But here's our triangle. Okay, so this will be A, this will be B. Let's do those in different colors, because that's basically what we need to find here. We need to find angle A, we need to figure out what angle B is, and we also need to think about what angle C is. So we're missing the three angles. Okay, so let's go ahead and let's say we first want to find angle A, let's say. So notice that this is an SSS triangle. They are giving me three sides. Now you can kind of run through your list. But when you have an SSS triangle, you have to use the law of cosines. Again, this isn't something I necessarily have memorized. I'm just going to look at the triangle and try to think about what tool I need here. Well, notice I can't use the law of sines here to find an angle. Remember, the law of sines says that the sine of the ratio of a sine of an angle to its opposite side is equal to the ratio of a sine of an angle to another angle to its opposite side. So if I tried to set up the law of sines, I would need to know at least one of the angles. You know, if I'm trying to figure out sine of A over 40, Well, if I try to set that up, I don't know what angle B is, so I can't do this because I have two unknowns now. Similarly, I don't know angle C either. So I can't use the law of sines here. I have to use the law of cosines. Okay. So if we're trying to find angle A, let's use the version of the law of cosines that has an angle A in it. So that'll be A squared is equal to B squared plus C squared minus a 2BC times the cosine of angle A. What I'm going to do from here is I'm going to take the law of cosines and I want to solve for the cosine of A. So the cosine of A, well, I'll start with A squared. I'll subtract off the B squared. I'll subtract off the C squared, and then I'll divide by the negative 2BC. So we have solved for the cosine of A. Okay. Let's plug in the other pieces that we need to know, our A, B's, and C's here. Notice here that this is basically saying that if I know the three sides of the triangle, then I'm able to find an angle. So that's why we need the law of cosines here for an SSS triangle. Given three sides, we're able to find an angle. So this is, this is side length B, this is side length C, and this is side length A. So we have the cosine of A is going to be equal to a 40 squared minus a 44 squared minus a 12 squared all over a negative 2. Our B is 44 and our C is 12. So we have that the cosine of A is equal to this. Now in the last video I did the cosine inverse of both sides and I kind of plugged it into my calculator and kind of one foul swoop. But what I'm going to do here just for illustration is I'm just going to go ahead and compute this right hand side to see what that number roughly is. So let's check it out. So 40 squared minus a 44 squared minus a 12 squared. Okay, and we'll divide that by a negative 2 times a 44 times a 12. So I'm getting that this is roughly, if we want to round to 3 decimal places, this will be 0.455. And this will be the cosine of A. Now, let's think about what this is doing. Let's draw a unit circle. So what is it saying? We're looking for the angle A. We're looking for the angle A that gives me a width on the unit circle of 0.455. Okay, so this distance here is roughly 0.455. Now this will be something nice to pay attention to once we get into chapter 7 when we're starting to solve trigonometric equations. But there are two angles on the unit circle that give us out this width here. Well, 2 on the unit circle. There's an infinite number of angles that give you a cosine of 0.455. But what we should remember is if we're using cosine inverse here, what angle is it going to spit out? Remember that cosine inverse, the way it was designed, only spits you out angles, I guess, between 0 and pi, or 0 and 180 degrees. So there are 2 angles here that do this. There's this angle here, theta, and there's this larger one from here to here. So I'll call this one theta 2. Notice that when we're looking at this picture, it doesn't make sense for a triangle to have an angle theta 2. Notice for a triangle, the sum of the angles of a triangle always add to 180 degrees, so it's impossible for one of the angles in the triangle to have an angle bigger than 180 degrees. So this green one doesn't make any sense to us. So we'll go ahead and erase that. Now, you could have blindly not thought about this at all, because when you plug into your calculator that A is equal to the cosine inverse of 0.455, this is fine because your calculator is going to spit you out this angle, this theta 1 angle, this acute angle. We should be expecting an angle between 0 and 90 degrees. So let's see this. So the cosine inverse of 0.455, I'm getting that this is 62.935. Notice here it spat me out this acute angle, or this angle between 0 and 180 degrees. It did not spit me out this one here. Okay, awesome. So I know that angle A here, angle A, we'll write it over here, angle A is roughly 60, I don't know why I wrote 69 here, I'm sorry, 62.935. That's the angle here. 62.935. Okay. Let's go ahead and let's try to now find angle B. Once we know angle B, we could easily figure out angle C by knowing that the sum of the angles add to 180. So let's go ahead and do that. So let's now try to find angle B. Angle B, okay? So we could use the law of sines here, or we could use the law of cosines because I now know angle A. However, I made a warning that we should always use the law of cosines when possible to find an angle, and I'll illustrate that doing it both ways. Let's first do it with the law of cosines. So angle B, I would need to use the law of cosines with a B in it, with the angle B, so we would have that B squared would be equal to A squared plus C squared minus a 2AC times the cosine of angle B. Okay, so if I solve for the cosine of B, that's going to be B squared minus A squared minus C squared all over a negative 2AC, solving for the cosine of B. Okay, let's plug in all our values. So the cosine of B here is going to be equal to, well, we're going to get a 44 squared minus a 40 squared minus a 12 squared all over a negative 2 times our A, which is 40, and our C, which is 12. Okay, so let's compute this and see what we get. So a 44 squared minus a 40 squared minus a 12 squared, close the parenthesis, and let's divide that by a negative 2 times 40 times 12. Need to close this parenthesis right here. Okay, let's see what we get. I'm getting a negative 0.2. The cosine of B is negative 0.2. Now, you could do the cosine inverse of this, and that's totally fine. Kind of blindly just kind of going at it. But I think it's going to be good for us to look and think about what type of angle it's going to spit out. Okay? Well, now I want to know at what angle gives me an x coordinate that's negative 0.2. So this here is negative 0.2. I want to know what angle does this. It should be this angle here, theta. Okay, I guess you could argue that there's this other angle down here that does this. There's this other angle. It goes from here to here. We'll call that theta 2. But notice that this angle here is larger than 180 degrees. And no angle in a triangle can be bigger than 180 degrees. So we don't care about this theta 2. And, well, what's great is if you do use cosine inverse to figure this out, it's going to report to you this purple angle. Because remember, cosine inverse spits you out angles between 0 degrees and 180 degrees. So what's nice here is this is actually going to tell me that B here is going to be bigger than 90 degrees. B is going to be obtuse. And B better be obtuse. So B, and I'll tell you why in a second. I mean, you could almost see from this picture that this angle here has to be bigger than 90 degrees. But B here will be the cosine inverse of negative 0.2. And let's see what this gives us. Let's do the cosine inverse of negative 0.2. So we're getting 101.537, if we're rounding to 3 decimal places, degrees. And that should make sense. I mean, that should make sense that I got something bigger than 90 degrees. We got this obtuse angle. So B here B here is going to be roughly 101.537 degrees. Okay, now we can go ahead and find angle C here, but I just want to make a comment. What if you tried to use the law of sines here instead? You could use the law of sines, but you'd have to be careful. So let's just say that we tried to use the law of sines to find B here. Okay, we first found angle A. So let's see. We could set up, if we were trying to find angle B, we could set up that the sine of B all over B, 44. Well, you're saying that that would be equal to the sine of A, which we got to be 62.935 all over its opposite side, 40. So we could solve for B here. So we'll get that the sine of B will be equal to 44 over 40 times the sine of 62.935. Okay, let's just figure out what this right-hand side is. So this is saying, what do we get? We get 44 times the sine of 62.935 divided by 40. So over here, I'm getting a 0.980 if we're rounding to 3 decimal places. Okay, so this is sine of B. Now it's good for us to think about what this is doing here. So if we're drawing this, now it's asking us for a height on the unit circle. A height on the unit circle that is a height of 0.98. So right here, let's draw that. It's a height. I'll say that the distance from here to here is 0.980. Okay, well there are two angles that give us this height. Well, there's the acute angle that could do it, and there's also the obtuse angle. There's also this obtuse angle, which I'll call theta 2. Well, notice here they're both between 0. They're both between 0 and 180 degrees. So I may want to think about both of them, but which one is sine inverse going to tell you? If you do B is equal to the sine inverse of 0.980 and you use your calculator, which one's it going to tell you? It's going to tell you the purple one. It's going to tell you the purple one because the way sine inverse is programmed is sine inverse only spits you out angles. It only spits you out angles between negative 90 degrees and 90 degrees. That's just how it's programmed. So we would have to mentally check whether this was the angle that we care about. So, I mean, notice here, let's just do it. Sine inverse of sine inverse. Okay, so this is telling me that the purple angle, that theta 1 is equal to 78.3390 for rounding to 3 decimal places, and this would be in degrees. Well, that's not what we got. That's not what we got over here. The angle that we actually needed was the obtuse angle, and because I used the law of sines, I had to mentally check which one I wanted. But sine inverse only is going to tell you the acute one. If I want the obtuse one, I have to do extra work. The actual angle that we wanted was the obtuse one. So we'd have to mentally see, oh, well, B should actually be 180. You know, if this is theta 1, then this will also be theta 1. So if I want this green angle here, that's what B will be. That'll be 180 degrees minus 78.390 degrees. So 180 minus 78.390. And we're back to exactly what we have here. Now here it says 101.61 degrees, but that's because there was some rounding issues, and that's why it's giving me something slightly different. So we just got to be careful in general. We have to be careful. Again, the rounding came from us rounding. You know, why these don't match up perfectly is, again, because I rounded here a little bit, here I rounded a little bit, so the answer's a little bit off, but it was this obtuse angle that we wanted. So what did we learn here? You got to be careful when using sines and sine inverses. Sine inverses will only spit you out angles between negative 90 degrees and 90 degrees. And when using them in a triangle problem, they're only going to possibly tell you this acute angle, and we'd have to mentally check to see if the obtuse one actually makes sense. But since cosine inverse spits you out angles between 0 and 180 degrees, I never have to worry about checking. It's always going to tell you the correct one, whether it's the acute one or the obtuse one. So just use the law of cosines to find angles when possible. Okay, so let's go ahead and finish this problem and figure out what angle C would be. So here, angle C, well, all the angles add to 180. So if I take 180 degrees and I subtract off 101.537 degrees and a 62.935, let's see what we get. 180 minus 101.537 minus 62.935, we get that angle C here. That angle C will be equal to 15.528 degrees. And this is the answer. Okay, so we found all of our angles. We've solved the triangle. Okay, let's do another example. Okay, so try. Solve the following triangle. Okay, let's say we know that B is 60, we know that C is 30, and we know that angle A is 70 degrees. Go ahead and pause the video and complete this triangle, or solve this triangle. Okay, let's do it. So let's draw our triangle. Okay. So let's see, angle A is 70 degrees. Angle A is 70 degrees. So I don't know, maybe this is roughly 70 degrees. Okay, so this here is 70 degrees, maybe even a little bit steeper. You don't have to be exact. 70 degrees. Okay, so this is angle A. Okay, here B will be over here, angle C will be here. Side length B is 60, so this will be 60, and here is half as short, so something like this. Okay, so this is angle B. This is angle B. Oh, sorry, this is angle C. And this is angle B. Okay, so we still need to figure out, what else do we need to figure out? We still need to figure out length A. Maybe I should color code this and put this as angle B, because that's we still need to find angle B. And we know this length here is 30, so we'll put a 30 here. We need to figure out angle C. Okay, there we go. We got 3 of the parts, we need to find the other 3. Okay. So let's see, which one do we want to do first here? Well, let's see here. Well, again, let's notice that I know this is a law of cosines video, but I can't use the law of sines here. I only know one angle. If I did the sine of this angle over this length, the sine of this angle over this length, I mean, I don't know what A is, but I don't know what side length A is, but I don't know what these angle B's are, so using the law of sines is going to leave me with too many unknowns. I have to use the law of cosines. Okay, let's see, I think we can use the law of cosines to find A here. Since I know this opposite side, since I'm trying to find this opposite side, and I know this angle, I think the law of cosines will work good here. So we'll have that A squared will be equal to B squared plus C squared minus a 2BC times the cosine of angle A. So we'll have that a squared. A squared is going to be equal to, let's see, this will be our b. Let's do that in green. This will be b, and this will be c. So we'll get a 60 squared plus a 30 squared minus a 2 times 60 times 30 times the cosine of 70 degrees. Okay, so we'll just use our calculator here. Okay, so we'll do 60 squared plus 30 squared minus 2 times 60 times 30 times the cosine of 70. Okay, so I need to take the square root of this, so I'm going to do to the power of 0.5. So how about I write this here? Here I'm getting that a squared. A squared is roughly 3,268.727. My calculator has more decimal places if you want to see what I plugged into my calculator here. And then I'm going to take this result and I'm going to raise it to the 0.5 power. So that's me taking the square root of both sides. So A will be approximately equal to 57.173 if we're rounding to 3 decimal places. Cool. So we have that A is 57.173. Cool. All right, so now let's try to find one of the angles. Angle B or C, doesn't matter which one. Let's see, we did angle B last time first. Let's find angle C here. And again, when we're finding angles, we want to try to use the law of cosines. So here, if I want to find angle C, I need to set up the c squared is equal to a squared plus b squared minus 2ab times the cosine of angle C. So solving for the cosine of C is going to be equal to c squared minus a squared minus b squared all over a negative 2ab. Okay, so we'll have that cosine of C. Cosine of C, what is our C? We'll have a 30 squared minus a 57.173 squared minus a 60 squared all over a negative 2. Our A is 57.173 and our B is 60. Okay. So let's see what we get here. Let's do 30 squared minus 57.173 squared minus a 60 squared. Let's divide that by a negative 2 times 57.173 times 60. Let's see here, a little syntax error. I think I had too many parentheses. Okay, so I'm getting that the cosine of C is equal to 0.86, well, I guess 870 if we're rounding to 3 decimal places. Okay, right off the bat, since I'm looking for drawing the unit circle, now you don't have to do this step. You could have just gone and done the cosine inverse of both sides to figure out angle C. But I'm noticing that I should be getting out an acute angle. I'm looking for an x coordinate that's 0.870. Here, this distance here is 0.870. It's going to spit me out this angle right here. Remember, cosine spits you out angles between 0 and 90 degrees. And so C, the angle that I'm going to get here, this would actually be angle C right here, will be, I should expect an acute angle. Okay, if it was negative over here on the right-hand side, I'd be over here and I'd have the obtuse angle. So let's do the cosine inverse. And just to kind of show you everything I have in my calculator. So I'm going to do the cosine inverse, and I already have the 0.870 or the 0.86998 blah blah blah. I can just hit cosine inverse, and then I can hit second answer. So answer is right above this minus sign here in blue. So I hit second answer and it's automatically going to put that in those parentheses. I can close the parenthesis. You probably don't have to close it, but I'm paranoid with parentheses. I'll go ahead and enter, and it's going to give us that C. That C is 29.543 degrees and acute angle, which is what we expected. Awesome. So we know that this angle here, C, is 29.543 degrees. Now, in this example here, if you did use the law of sines, you would have got the right answer because the law of sines will only tell you acute angles. Okay, or when you're using sine inverse, it'll only tell you acute angles. So you would have got away with it in this problem, but in general, you need to be careful. Okay, we're pretty much done. We just need to figure out angle B. Now that we have two angles, really easy to find the third one. We need to figure out what angle B is. So that'll be 180 degrees minus 70 degrees minus 29.543 degrees. So let's see what we get. 180 minus 70 minus 29.543. So I'm getting that angle B is 80.457 degrees. And that's the answer. Okay. If you found angle B first, our answers might just be slightly off because when I was finding C here, there's some rounding errors here from using this A here. So I don't know, you might have something that's ever so slightly off and just kind of depends on the order at which you're doing this. So. Okay, I hope you found this video useful. The big thing here is that we can use the law of cosines to solve a triangle, but the big thing we want to remember is whenever we're finding angles, I highly recommend using the law of cosines. You can use the law of sines, but you have to remember sine inverses only spit you out angles between negative 90 degrees and 90 degrees. So sine inverse will only ever tell you the acute angle. Sometimes it might be an obtuse angle, so you either have to draw a picture of the unit circle or just use cosine inverse instead, and you don't have to worry about anything. Okay, we'll see you in the next video. Take care.